Okay, so let's continue with some review. Number 8, question is as follows. Find the absolute extrema, so maximum and minimum, of the function f of x equals x power 1/3 minus x power 2/3 on the interval -1, 1. All right, so basically what we want here is to find where does this function reach a maximum and a minimum on the interval -1, 1. So do you remember what to do here? We find the critical numbers by finding when the derivative is 0 or where it doesn't exist. Okay, so the function is defined from -1 and 1. There's no problem here. So let's find, we first find all critical numbers on -1, 1. Okay, so f prime, so the derivative is equal to what? So the derivative of this 1/3 x to the -2/3 minus 2/3 x to the, I think, -1/3. Okay, I'm going to factor out what can I factor out here?
You factor out a negative x to the -1/3.
X to the -1/3, and then what?
And then, sorry, x to the -1/3 over 3, and then you get x minus 2 left. You can factor it out like perfectly.
Let me see if I factor out x to the -1/3. Yeah.
Yeah, I got x minus 2 times x to the -1/3 over 3.
How did you get x minus 2?
Because what I did was I factored out the 1 over 3 x to the -1/3.
Okay, so you factor out the x to the -1/3, I agree.
And the
But
1 over 3.
what's going to be here? You're still going to get x to the -1/3 here.
Sir, I think there are people in the waiting room.
Oh, thank you. Okay. So,
Wait. Wouldn't it be x to the 1?
sorry,
Wouldn't it be x to the, wouldn't it be just x?
x, and then what? Okay, so I'm waiting for your help here. What should I factor out here?
I factored out 1 over 3 times x minus x to the power of -1/3.
So 1 over 3, I agree with you.
Yeah.
But if you factor out x as -1/3,
Yeah.
then what's gonna, I'm gonna write it in pencil, okay? So I could erase if it's wrong. So let's say I'm following your track. So I pull out x as -1/3. So what's here? X is -1/3 minus 2. You understand? I still have a negative here. So that's not very useful. Okay, so we have to find something else. me out.
Or don't we have to say that the function is equal to, or the derivative of the function is equal to 0 though, when we find the extrema?
Yeah, yeah, but for now, I'm just finding the derivative and making the derivative, simplifying the derivative the best I can.
But couldn't we just right away say it's equal to 0 and then send 1 to the other side and then simplify that way?
I'm sorry, I didn't understand what you said.
Could we say that f prime of x is equal to 0 and then send the negative 2 over 3 x to the power of negative 1 over 3 to the other side of the function and then simplify that way?
Yes, you can. You can. But there's something, okay. There's something else to do here. So I'm going to do it the long way. Okay. You're right. But now you're just showing, from what you're doing, is you're showing when the derivative is 0. But that's not the only critical numbers. Critical numbers are also when the derivative doesn't exist. Okay. And the way you're doing it, you won't see these. Okay. So I have here 1 over x to the 2/3 minus 2 over x is 1/3. Is that okay?
Mhm.
Okay. So let's find, yes?
Can you explain how you got that?
Because the negative exponent means it goes down. When the exponent is negative, it goes down.
Oh, okay.
Okay. So equals 1/3. And I'm going to find the common denominator here. So I will multiply by x to the 1/3 here, top and bottom. Okay. So I'm going to have 1 minus 2x to the 1/3 over x to the 2/3. You guys okay with me? No questions? Okay, so this I could pull in front. So 1 over 3x to the 2/3 times 1 minus 2x to the 1/3. That's it. This is f prime of x. Yeah, that's how I would have done it. Okay, so now I see my derivative, and I see that to find my critical numbers is when this expression is either 0 or doesn't exist. Okay, so f prime of x is equal to 0 if, of course, this is 0. So 1 minus 2x 1/3 is equal to 0, which means that 1 is 2x to the 1/3, which means that 1/2 is x to the 1/3, and you power 3, x is 1 over 8. So that's already one critical number. Okay, and f prime does not exist if, right, my denominator here is 0. So if x is 0. So this is another critical number. Are you with me?
Sir, can you explain the second step again, where you're finding the derivative?
The second step, you mean this?
No, just under.
This?
Yes.
Okay, well, the only thing I did from here to here is I multiplied this by x to the 1/3, top and bottom. Okay, so x to the 1/3 is here, and then x to the 1/3, x to the 1/3 is x to the 2/3. Here it is. They're both over x to the 2/3 now. It's not clear?
I get it. Thank you.
Okay. Okay, so now at this point, the only thing we need is we were looking for the absolute max or absolute min. So we're going to evaluate the function at my endpoints and at my critical values, 0, 1 over 8, and at 1. Okay, so I'm just gonna rewrite the function here. F of x is x to the 1/3 minus x to the 2/3. So let's go. If I plug in -1 here, so I get -1 minus 1, so I get -2. Okay, at 0, of course, I get 0. At 1/8, so at 1/8, I get 1/2 minus 1/4, so that's 1/4. And at 1, I get 1 minus 1 is 0. That's it. So here's my minimum, and here's my maximum.
Bruh.
Questions? So more or less, if I'm to give you what the function should look like, okay, so at 0, it's 0. At 1, it's 0. Then at -1, it's -2. And at 1/4, it's 1/8. Okay, so it looks something like this. So sorry, at 1/8, it's 1/4. Sorry. There you go. It looks something like this, and you see you have the max here, which is 0.1/8, 1/4, and then you have the min here, which is -1. That's it. That's another exam question. Good. Let's go to another one. So the next one will be a related rates question. So I just wrote down the question. I typed it so that I don't have to rewrite it here. Here it is. So again, this is a exam question. Okay, take 2 seconds to read it. Okay, let's do it. Let theta in radians be an acute angle in a right angle triangle, and let x and y be respectively the lengths of the sides adjacent and opposite to theta. So basically, the situation is like this. I have a right triangle. Angle theta, adjacent is x, opposite is y. That's what's given to me. Okay, now they tell you that x and y vary with time. Okay, so dx, there's a dx dt and dy dt. There's a speed at which x and y change. At the instant when x is 2 and increasing at 4 units per second. So right there, I know that dx dt is equal to 4. And y equals 2 and is decreasing at 1. So dy dt is -1. How fast is theta changing at that time? So we're looking for d theta dt when x is 2 and y is 2. This is my question. Is this okay? You understand? Okay, so if you manage to set up this, you already have the problems done. The rest is just calculations. This is the harder part. Okay, so again, what's given to me, x is increasing at 4 units per second. So dx dt is 4. The variation of units per second. So units per second. Okay, distance over time. Same thing for y, decreasing at 1 per second, at also -1 meter per second or centimeters per second, who cares? Okay, so we need a relation between theta, x, and y. What are we going to use?
Tangent.
Tangent of theta is equal to y over x. And so I could now derive. Okay, so the derivative of tangent theta is secant theta times d theta dt is equal to, what is that? What's this derivative?
Y prime.
What?
No, dx dt over dy dt.
dy dt over dx dt, you mean?
Yeah, dy dt over dx dt.
Are you sure about this?
It's a quotient rule.
As a quotient rule.
It's a quotient rule. Okay, be careful. So dy dt
Sir,
times x. Yeah,
isn't it secant squared?
yeah.
Theta.
Thank you. Yeah, I forgot. You're right. Minus the top times the derivative of the bottom divided by the bottom squared. Okay. So let me check here. Dx dt I have. Dy dt I have. X I have. Y I have. X I have. The only thing missing is theta. Okay, and of course the theta dt is what I'm looking for. Okay, so how are we going to find theta? Okay, so x is 2, y is 2, theta is what?
Arctan of 1.
Arctan of 1, which is pi over 4. Okay, 45 degrees. Okay, if x and y are the same, so obviously this is 45 degrees. That's why it's pi over 4. Good. So I'm going to write it right next to it. Arctan of 1. Okay, which is 2 over 2. So that's it. So now I have this. I have the theta. So let's go. Secant squared of 45. What is that? What is the secant of 45? So secant is 1 over cos. Cos is 1 over root 2. 1 over cos root 2, 2. So I have 2 here. 2 times d theta dt is equal to, so here we go, -1 times 2 minus 2 times 4 divided by 2 squared. And that's it. I could find d theta dt right away. So minus 2 minus 8 is minus 10. Minus 10 divided by 8 is -5 over 4 radians per second. Okay, and that's my answer, like you see here.
Sir,
Yeah.
could you repeat how did you get the 2?
How did I get what? I'm sorry.
2.
Oh, the 2 here?
Yes.
Yeah, no problem. So this is let's move up a bit. So secant squared of, so we said theta is pi over 4, right? This you agree?
Yes.
Okay, so this is equal to 1 over cos squared of pi over 4. which is 1 over cos of pi over 4 squared, which is 1 over, so the cos of pi over 4, you have to know that it's 1 over root 2. And so if you flip, you get root 2 squared, and that's 2.
Okay, thank you.
Good. Okay, another one. The next question in the exam was a optimization question. Here it is.
Sir, so basically there's just like one question per topic.
Well, it depends on the exam. Yeah, but you know the question on limits was there was like 5 of them. But yeah, pretty much, you know, the final exam is just to make sure that you understand everything. That there's no part that's not covered. So you know, there's a lot of topics. Yeah, chances are you're going to get everything's going to be tested. If you need to know, that's what's going to happen. Okay, let's do this one. Michael has 28 meters of fencing to enclose 2 separate turtle pens. Okay, I guess turtle pens is a whatever, a certain region. Okay, one pen would be a rectangle 3 times as long as it is wide. So the first one, a rectangle x 3x. That's the first one. And the other pen will be a square. So I guess y. Okay, it's a square. Okay, the width of the rectangular pen should be at least 1 meter and at most 3 meters. Okay, so it's given to me that the width, so x, is at most 3, at least 1. So they just gave us our bounds. Find the maximum and minimum total areas of the pens. Okay, so we're going to maximize the total area. Okay, so what's given to me? 28 meters per total perimeter is 28. So 3x plus 3x plus x plus x. So I'm going to write this here. So we know that x plus 3x plus x plus 3x plus 4y has to equal to 28. So 8x plus 4y is equal to 28. If you divide everything by 4, 2x plus y is equal to 7. And so y is 7 minus 2x. Okay, so far?
Yeah.
Okay. And we want, so this is what we know, and we want to optimize. Okay, so here it's both. They're asking us to maximize and minimize, but the total area, which is 3x2 plus y2. Okay, which is 3x2 plus y2, so 7 minus 2x squared, which is, so 4x2, so 7x2 minus 7, 14, 28x plus 49, okay, on interval 1, 3. That's it. This is my problem, which is pretty much like we've done a lot, finding the maximum and the minimum of the function over an interval. So we find the critical numbers and verify when we get the max and the min, right? So this is an easy question now. Okay, are you okay until here?
Yeah, I think someone's in the waiting room again, though.
No, I think I let everybody in. But do you see when somebody's in the waiting room or they're texting you?
No, someone in the chat, like in the text said that.
Okay, perfect, because I see no one here, okay? So let's go. A prime of x is equal to, so 14x minus 28. When is this equal to 0? When x is equal to 2. And that's it. So now I'm going to find the area at 1, the area at 2, and the area at 3. Okay, so at 1, 7 plus 49 is 56. 56 minus 28 is 28. Okay, meter squared. That's the area here. At 2, so I think I need a calculator for this. So at 2, I get 28 minus 50 is negative 28. So 49 minus 28 is 21. And at 3, I get 63 minus 28 times 3 plus 49. Oh, 28 as well. Okay. So that's it. So the maximum area. Oh, the answer is here. I saw the answer. Maximum area is 28 meters squared, and the minimum area is 21 meters squared, just like our answer says here. Sorry. Okay. Okay. Are we good? Continue. Okay, for those who just got here or got here late, okay. I have to leave at 10:40 today, okay? So we have about 7 minutes left, okay? So let's do at least one more. So that was question, I think 8, 9, I don't know where we up to. 8, 9, 10. So let's go 11. Okay, so given f of x is equal to the square root of 100 minus x2, defined on -6 to 8. Okay, so find all numbers C that satisfy the mean value theorem. Okay, so you remember how to do the mean value theorem? So it would be f prime of c is equal to f of 8, so at the bounds, minus f of minus 6 over 8 minus negative 6. That's what I'm looking for, basically. Okay, so I'm looking for c that solves this equation. So first we need to find the derivative. So the derivative of this will be negative x over the square root of 100 minus x2. Okay, and here, what will I have here? F of 8. So if you plug in 8 here, you get 64. 100 minus 64 is 36, or 6. Minus, if you plug in 6 here, you get 36, 64, 8. 8 over 8 plus 6 is 14. And so you get negative 2 over 14, so negative 1 over 7. Okay, so if I want to solve this equation here, so this has to equal to negative 1 over 7. Okay, so I could cross out the minuses. So 7x is equal to the square root of 100 minus x2, square both sides. Well, first of all, actually, x has to be positive at this point, or else you cannot have a square root of a negative number. So x is at least 0. Right away, I have a restriction here. And so we solve. Square both sides. 49x2 equals 100 minus x2. So 50x2 is equal to 100. X2 is equal to 2. And so x is equal to 2, or x is equal to, root 2, or x equals negative root 2. Okay, so obviously, because of my restriction here, this is disregarded. And so that's my answer. X is equal to root 2 is the value.